We will wait for 4 or 5 minutes more. So there will be participants.
Yeah, that's fine.
We will wait 2 more minutes and then we can start the meeting. Shall we start, sir?
Yep. Okay.
Is the
So
presentation visible?
yeah, I can share that. Yeah.
Okay. So good evening, everyone. A warm welcome and thank you for joining us today. For my introduction, myself Pranav Marathi, a chemical engineer with close to 4 years of experience in clean energy and sustainability consulting. Working with Greenstat Asia, my experience primarily spans across green hydrogen, industrial decarbonization, emission assessment, techno-commercial analysis, and sustainability strategy across sectors like cement, textile, oil and gas, and city gas distribution. And I will be host for the webinar. And welcome to session 2 of the Hydrogen Safety and Risk Assessment Webinar Series 2026, organized by Greenstat in partnership with DNV. Today's webinar overview of DNV software suite, PHAST Safeti and KFX. We'll introduce DNV's industry-leading software used for consequence modeling, quantitative risk assessment, also known as QRA, and process safety, highlighting how these tools support safer engineering and informed decision making. Before we begin, a few housekeeping reminders. This session is being recorded and the recording will be shared with all registered participants. If you have any questions, please post them in Q&A box throughout the session. We will address them during the Q&A at the end. And now it is my pleasure to introduce today's speaker, Mr. Nagmani Kumar Sinha, Sales Specialist at DNV Digital Solutions, India. With over 25 years of experience in process safety, quantitative risk assessment, asset integrity, petrochemical, and oil and gas sectors, Mr. Sinha has spent more than 16 years with DNV, helping organizations implement industry-leading safety and risk management solutions. He is also certified as a professional and has conducted numerous technical workshops and client training programs across India, the APAC region, and the Middle East. We are delighted to have him with us today. Without further ado, I would like to hand over the session to Mr. Nagmani Kumar Sinha. Sir, the floor is yours. Thank you.
Thank you, Pranav, and good evening, good afternoon, everyone. And yeah, so as Pranav has introduced about me, I've been working with DNV for last 16 years, and I've been working in mostly oil and gas or maritime or petrochemical sector all throughout my career, and has been dealing with this hazardous material in some form or the other. So today's agenda is to talk about the softwares of DNV, which is used as a leading tool in this hazardous industry to do the hazard analysis and risk assessment. We'll start with FAST and Safeti if time permits today. We'll show you a bit of KFX also, but if time does not permit, we'll keep that for some other day. Okay, so the agenda for today is basically I would like to show you something about QRA and what is consequence and QRA results, what kind of results you have, and also will show you some 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 screens of software, both fast and Safety, to showcase how effortlessly a trained user can calculate the consequence results or can work out a QRA results or report effortlessly if they are trained. To start the presentation, I would take a minute to talk about DNV, and after that, we'll straight away go to the subject, which is fast and Safety introduction and KFX introduction. So DNV is a independent assurance and risk management company, has been in the business for 162 years with more than 12,000 employees, 100,000 customers, 100 plus countries. And DNV is proud to say that they invest around 5% of their annual revenue on R&D. There's three different verticals DNV has. One is ship and offshore, which is the maritime advisory and classification company. Then we have a big group for energy advisory, certification, verification, inspection and monitoring. And then the last but not the least is management system certification, product chain and product supply chain and product assurance. The company which does this, all the certificates like ISO. And DNV purpose is to safeguard life, property, and the environment. And DNV vision is to become a trusted voice to tackle global transformation. I believe the purpose and vision sounds something really amazing, and this should be the purpose and vision of almost everyone who is in business, or if you're doing anything, unless you are ready for global transformation, you will be obsolete. And if you don't safeguard life, property, and the environment, the world will not be livable after some years. So let's start with the topic. We'll start with some definitions, very short, and then we will straight away go to the topics. Why I'm talking about these definitions is just to do a kind of a warm up, like what you are going to see today, and whether these concepts are giving you some kind of a stimulus to learn more about these things. So what is hazard, what is accident, and what is risk? So definition of a hazard is physical situation which have the potential to cause harm is hazard. So look at the definition. It says potential to cause harm. It is not actually harm. So not all the hazard is causing you harm, but it has a potential to cause harm. Then what are accidents? Accidents are the actual realization of a hazard. So a hazardous operation has the potential to cause harm, but it does not happen every day. But sometimes, someday, accidents do happen, and that hazard which was contained in that process comes out. Means you understand that what hazard this process is carrying. And what is risk? So risk is the combination of likelihood and consequence of such accidents. So our subject today will be revolving around these things. This is a nice definition of risk. Risk has multiple definitions, but this one is one of the best definitions of risk is the likelihood and consequence of a specified undesired event occurring within a specified period or under specified circumstances is known as risk. And what is safety? So safety is the inverse of risk. The higher the risk of any level of harm from an activity, the lower is its safety. So it's like when you are entering a plant and you say this plant is very safe, that means the plant is not very risky. The opposite is also true. You go and enter a plant, and if you hear that this plant is very risky, that means it's that unsafe. So all our effort is to understand the unsafe character of a plant and make it safer. What is risk management? Risk management is the systematic application of management policies, procedures, and practices to the task of analyzing, evaluating, and controlling risk. So please look at the definition. It's like it talks about systematic application of management policies. So risk management in a plant is top driven. It is not like the worker who are working on the ground will go and tell the CEO that uh, we need to be more safer, or it's basically if management is aware, management has that kind of approach, Then they push this safety policies and safety different kinds of safer norms, which is practiced widely in the plant. And you so this risk management is generally top down. This is a typical risk management workflow, and you start with identification of hazard, and then you postulate accidents with the hazard identification you do generally in HAZOP or PHAs, which is done in plant at different stages. When you have made some notes like that, these accidents can be possible, then you go for further analysis of those accidents, and you start consequence evaluation. Means you do consequence analysis. People who do QRA, they make the frequency chart, like the different equipment which is which has a potential to fail, they make a frequency for that. And then you do a risk summation. So consequence and frequencies together give you the risk number. If the risk is managed, then we just optimize and the cycle goes again. But if the risk is not managed, you have two ways to reduce the risk. Either you mitigate the consequence or decrease the frequency. How you mitigate the consequence? You can change the parameters of the process, like you can reduce the volume, you can reduce the pressure, or you can make, if there was a one tank was having X capacity, you can make two tanks with 0.5x capacity. Like that, you can separate the volumes. That way, you can mitigate the consequences or reduce the consequences. Or option to decrease the frequency, you can change the equipment or the process itself. Structure of a risk assessment starts with system definition. So you define the installation or the activities whose risks are to be analyzed. The scope of work for the risk assessment should define the boundaries for the study, identifying which activities are included and which are excluded, and which phases of installation's life are to be addressed. And so this slide is more means it is more for consultants who work for these kind of job. So when they start the risk assessment, the first thing which they should be doing is they should define the boundaries for the study. Then hazard identification, which will be mostly qualitative. And then QRA is, so you can have two kinds of means one is qualitative evaluation, which is like your HAZOP, and you make some risk assessment based on your judgment, your experience. And then there is QRA, which is having a defined mathematical modeling to do quantitative risk assessment. And when you are doing this QRA, your objective should also be to find out which is creating these risks. So you should find what are the major risk contributors. So this will help you to understand the risk drivers. And once you understand the risk drivers, it helps you to focus on risk reduction measures. So risk indicators can be types of outcome, jet fire, pool fire explosion, LFL, UFL, hole sizes. It can be anything which is giving you that risk. And if you understand that, then you can control or you can reduce the risk by controlling those major contributors. Risk management hierarchy is level one is elimination by design, inherent safety. Level two is prevention in by daily management, maintenance and inspection. Level three is control and limitation is level four. So by operation of engineered safety systems and emergency response. This is level five, escape, evacuation and rescue. So a plant has all five levels of risk management hierarchy, but best is if you eliminate at level one, means you by design and you make the plant inherent safer. Depending upon the risk assessment, opportunities for risk reductions are explored. By investigation of events resulting into higher contribution of risk, the risk reduction measures are proposed, which may be towards termination of the risk. So selection of hazardous material with non-hazardous material. There is some cases, some examples, but not generally an option. But if you are handling with say something coolant or something where you can replace the coolant from a hazardous material to a non-hazardous material, something like that, but not the core process cannot be changed, but still the process which is assisted with some non-core material that can be changed if possible. Facility siting of critical building away from hazardous zone. And the second could be reducing likelihood of key events, reducing number of joints, potential leak sources, increasing pipeline wall thickness, design factor and burial depth for pipelines, mitigation of consequences, severity and impact, limiting inventory by provision of quicker isolation method like FNG detection with remote isolation, addition of remote isolation valves for hazardous inventory handling equipment, provision of dikes, HVAC system, fire related and blast protection buildings, fire rated and blast protection building. So now means in if you visit a plant, a refinery, or you will see some of the constructions are made in a way that they do blast proofing, and that is done with a different material. It's not the regular material of construction. So to understand that, you need to understand the risk. So same. So all these things I had discussed about is only to give you why it is important to understand the risk, why it is important to do a good kind of analysis. So because all other things depends on your ability to correctly predict or correctly estimate the hazards and risk associated with it. So a QRA report, which can be an output of Safeti, is like you get LSIR, individual risk per annum, potential loss of life, FN curve, major risk contributors, process and non-process. Some of the slides, I think I should have hidden because this is not essential for you to understand all these things, but because this is very basic. But I okay. So let's go to the subject, which is so how you evaluate the risk. So evaluation of risk is done by understanding loss of life, impairment of safety functions, property damage, business interruption, environmental pollution. So these are the risk elements. Means if I have to evaluate a risk, how I say that, okay, fine, this is like this can have this many people injured, or this can have a loss of life. If safety functions are impaired, then that means escape routes is impaired. So then it'll not be possible to rescue people easily. If it is the offshore, then so means you need to understand all these things to evaluate the risk. There can be property damage, there can be business interruption. So say when you go to a customer meeting, or when you go to talk to somebody about that, understanding a consequence analysis or understanding a risk analysis is very, very essential. But this does not give you any commercial benefit. What benefit it gives? There's no distinct benefit of doing a consequence analysis. It is not going to increase my production. It is not going to it is not going to increase my revenue, or it is not going to give me any kind of financial benefits. But not giving financial benefit is one thing, but saving financial losses, it definitely does. And it does by giving you an idea of how to save life, how to deal with critical situation, what kind of losses it can have if something goes wrong. So people say, no, the safety is not important. Then tell them, there is a saying that tell them that see what expense an accident has. Now I'm introducing the software PHAST. PHAST stands for Process Hazard Analysis Software Tool. This is a tool which is very popular globally to do consequence analysis. And what PHAST can do is you can estimate the magnitude of consequences. You can review siting, layout, and design. Say in India, I think abroad also is true. Without a single exception, I have all EPC companies in India using PHAST software. And what do they do with this? When they do detailed design, they check the design, they check the safety measure, or they check whether the consideration which is taken to do the siting is correct or not. Whether the same level of proofing which has been considered is good enough or not. You can do this by doing these analysis. If there is any modification in the plant, you can estimate the effects of modification with the help of this software. It helps you to prepare for your emergencies. So it fast helps you for emergency preparedness. It helps you to comply with regulations. insurance estimations and negotiations, promote safety awareness, and QRA study is starting here. Means, sorry, you start a QRA study with FAST. So if you see this flow chart, it is the same flow chart in a different way. Means you get the plant data, do hazard analysis, derive failure cases, and you input generic failure rate, and you do consequence analysis with meteorological data. You don't enter, means for fast, you limit it to consequence analysis. And only thing which goes in fast apart from the process parameter is weather parameter, meteorological data. The other part which you see here is all will come in Safeti, like frequency calculation, population data, ignition data. I I'll now show you some of means the software, but if you have any questions, we can take it now for a few minutes and then I'll go to the software and confirm once you see the software screen.
If anyone has any questions, you can raise your hand. We would unmute you and you can talk, or else you can put your questions in the Q&A box.
Okay, Pratika, I can't see those chats and all, so you have to read it for
Yeah,
me if
sure.
there is, yeah.
Sure. I'll read it. Nobody has any questions at this stage?
Yeah, allow me to ask a question, please. This is Devendra this side.
Please go.
Uh, Sir, it has been seen that when we are doing the QRA for a modification or bringing some new facility, so without having the existing QRA reports of the existing units, how we can do it? Because sometimes clients is reluctant to share the old reports or the existing facility. How it can be addressed?
Mr. Rathor, right? If you can introduce yourself, then I can answer you first. First, you introduce yourself, sir.
Yeah, yes, sir. My name is Devendra Rathore, sir. I am a PSM engineer working in KNPC Kuwait.
Okay, great. Okay, all right. So, see, QRA is done even for the first time as well. It's not that for QRA, you need the base files of a company. It's not, means I would not say that it is needed, but if you are doing sensitivity analysis, then the base file is needed. Now, uh, if you repeat your question once again, then I'll answer it well. So which data you are telling that previous QRA report is not
Yes,
being
sir.
given?
Yeah, because
Huh.
the old care reports are not accessible, or over the time it has misplaced or something like this. So in case we are coming up with some modification of the units, so in case how to do the QRA of the, will it be fruitful to do the QRA for the particular modification only without considering the overall facility, the existing units, I mean to say.
It's a very different question, which requires different kind of, deliberation. I will not uh, get into this detail, but QRA, if you're doing for one particular unit and you are not doing for the entire plant, say process wise, there is nothing wrong. It can be done.
Yeah.
But what you may not be getting is the impact coming from other units on your the unit which you are currently considering for the QRA. So theoretically, it is it is fine to do QRA for a unit inside a plant, even if you don't have uh, previous QRA from other parties or for the full plant and all. But practically, you may need the data of the plant. It is not possible to deal with any hazardous plant. Means say generally in plant QRA, in QRA, what you get, you need to define the plant boundary, and also you need to see the basic impact, the first impact, like what is the distance
Yeah.
of dispersion and all that. If it is going to the associated plant, so then in the other area, then that has to be seen that what is there. But to do a modification, say QRA, QRA, I think it's a very different topic. If you're doing analysis, consequence analysis, yes, it can be done. Even QRA is being done. But whatever you do, even if you do, say, in an industrial unit, you have 10 different plants
Right,
and
sir.
you do one plant, means you carry out QRA for one plant. It is done, right? It may
Yes,
not be
sir.
100% true, 100% correct, because you are not able to assess the risk coming from other plants,
Yes,
which,
sir. We are doing this standalone QRA for this
yeah,
modified facility or this one. Yeah.
yeah. So I don't see theoretically it is wrong, or but I would definitely say that if you include everything, then probably that is a better, but that will be a very big exercise. But
Correct, sir. Correct. Yeah.
what is most important is whether the distances which you are getting from the modified plant is covered for the risk which you are considering or not. Because if it's a toxic release or if it's a flammable release, what kind of distance it is with the other units, that those things needs to be taken into consideration and can be flagged that this can be a potential risk to other plants. But otherwise, if it has to be it has to be worked as a QRA for that, it should be possible. I don't see that is not possible.
Okay, sir. Okay. Okay. Thank you, sir. Thank you. Yeah.
Can we proceed with the software demo?
Yes, sir. I think we don't have any other questions in the Q&A also. I think we can
Okay.
proceed.
Okay.
Thank you.
Okay. Right. So this is the base screen of FAST software. You get this work area, then this ribbons for different commands, like you have file, home, settings, tools, data, view, help, general input. As I go along, I'll tell you that what all this means. Yeah. So So this has few tabs. The first tab is model tab, then weather tab, then parameter tab, then material tab, then map tab, and then this effect tab. So we will limit it to first five tab. We'll exclude this effect tab for today's session. So this effects tab is with the software. If the software has uh, effects license, say we have a explosion model extra additional in FAST or Safeti. So if a user has this license, then this effect tab is visible. Otherwise, this effect tab is not visible. So if I want to do a new study, so you may start with inserting a new map, a new layout, scale it, and then start inserting the models on that map or layout. Even if you don't have a map or a layout, still the studies can be done. It is not essential to have that, but it is good to have the equipments put on the map or a layout. In FAST 9.3, I'm showing you today FAST 9.0 because I do not have the current software because there were some technical issues with my laptop. So I've not upgraded it to FAST 9.3. But in FAST 9.3, there is an option to do with live map. You can actually, because FAST 9.11 onwards, it takes, when the software takes internet uh, connection as well. So you can actually go on live map and figure out your plant, and you can actually put your equipment on the live map. It's a real Google map and can see the different levels of I mean, a very good resolution, though it's a beta version right now, but it is possible now to directly put the study on Google Map, Google Earth. Yeah. So let's, so, and when we are doing fast study, what is our concern? What we want to do when we are doing a fast study? When we are doing a fast study, we are actually modeling discharge of a material, and then this discharge, once the material is discharged, then the weather takes comes into picture, and with the wind it disperses, and with dispersion you have three different kinds of scenarios. It can lead, if it's a toxic, it can lead to toxic release, and then toxicity can spread, and then you have to find out what is the concentration and what is the distance of a particular concentration, which can be fatal or which can be risky for people in that area. If it is flammable, then if there is a fire, what kind of heat is generated, what kind of radiation is generated, and if it's an explosion, then what kind of overpressure is generated. So these things are calculated with FAST software.
Sir, we received one question
Yeah.
from Mr. Saraswat. The question is, if we don't have the plot plan or layout, then how would you see the contours and distances? And how can
Okay.
we get LSIR contour, etc.?
LSI, we are in FAST software right now. We are not in Safeti. So I'm talking about consequence analysis right now. I'm not talking about QRA. So for consequence analysis is not used only by the QRA consultant. This is also used by engineers. They do engineering with consequence analysis. So basically for design inputs, say if I want to know that this particular material is leaking and what will be the distance that you can get. So in FAST gives you report, FAST gives you graph. So there you will get all the data, what distances, and say it'll not be plotted on the plant, but it will not be plotted on plan, but still the say what difference it has is when you have a layout, it puts the you know the the dispersion characteristic on the plot plan. So if you want to see fire or dispersion or concentration, you can see on the plot plan. So please wait. We are not yet into Safeti or LSIR or FN curve. This will be the topic of discussion when we start Safeti or when we start the second software. We are right now on FAST, and FAST is basically for consequence analysis, and consequence analysis is the first step for QRA. But consequence analysis is done by multiple uh, uh, multiple streams people, not only the QRA consultants do the consequence analysis. I hope it's clear. Okay, so FAST has liquid, gas, or two-phase flows, single or multi-component materials, steady state or time-dependent behavior, and in-building releases. So it deals with all these kind of discharges. A fast dispersion gives you aerosol formation, rain out, pool vaporization, pool formation, and air entrainment and cloud spreading. And for toxic effects, you get concentration as a function of downward distance, concentration as a function of time, cloud footprints, profit values, and lethality. For radiation, you will get possible flammable outcomes like fireball, jet fire, pool fires, flash fires, and results are shown in the form of radiation intensity level, radiation dose levels, radiation lethality levels, and flash fire zones. For explosion, software has four different models. It has TNO, it has Baker-Stillo, it has TNT, and Blavy Blast. Blavy Blast, you should not keep it as a separate explosion model, but uh, it's a different kind of a scenario for some of the materials like LPG. And then results are shown in the form of overpressure versus distance, pulse duration versus distance, and impulse versus distance. FAST has the ability to place graphical results for dispersion and effects over map, which I was talking. So if you don't have a map or if you don't have a layout, it will still form this graph, but it will not be superimposed on this map. That will be the only difference. So if you go on GIS tab, and if not uploaded any map or layout, these curves will still be there, but you will not be able to visualize it where it is happening. So if your interest is only to understand how much distance it is going, you can still do, means you can, it's a choice. It's not that you should be doing without map or without, but for smaller studies, people can model without even a map. Or say if I'm testing something, I can run different combination without map also. Map is not really essential to run the results, but map is a good tool to understand the result. So it displays results for odd dispersion and effect results for the case, different wind direction, dynamic animation, multiple releases, can view shape or effect zone. Let's go to the PHAST software now and see a study. So I'm selecting one fast example study and will take you to the study and results, and will show you how the results and how the inputs are being fed in the software to generate the results which you need. Okay, so see, I understand that this meeting is called for a specific purpose, but today we are starting with the software. So we'll just show you how you start doing the basic calculation in this software. So as I said, you have model tab, and let's open one study. So we are right now doing a LPG sphere. So how you reach here, you select a material, LPG selected, then give the volume, give temperature, give pressure, and these are the basic bare minimum inputs required in a software to do the consequence analysis. If you have mass, then you can go to mass inventory. If you have volume, then you click this and go to a volume inventory. So these units have different units. So if you change this unit, if you don't have in meter cube, you want to use some other, you can use it. Same in temperatures, same in pressure. So there are option of multiple units. Once you have put the basic inputs, then you insert different kind of releases. So in this example, they have modeled catastrophic rupture, leak. So two different kinds of scenarios they have modeled. One is catastrophic rupture, which is full bore rupture, and then one is 25 mm leak, one is 50 mm leak, and one is 150 mm leak. So 25 mm leak is for, you can consider small leak, 50 mm medium, and 150 mm large. But when you start doing this kind of analysis, please note that is 25 mm, 50 mm, and 150 mm is no standard. It's not standard. It is just taken randomly, like a representative sample of 25 mm, 50 mm, and 150 mm. You can select 20 mm, you can select 30 mm. You can also select 5 mm leak. So pinhole also you can select. But this is just taken as an exercise to showcase how the software works. So when we select catastrophic rupture, in catastrophic rupture, you don't need to give any other input. By default, the software has taken 1 meter elevation and tank head 0. All the green symbols means this is already populated with some values, which is by default DNV has assigned. For a liquid leak, you need to provide the orifice diameter, elevation, tank head, then the release direction, horizontal or angled from horizontal, vertical, down impinging, horizontal impingement, angled from horizontal impingement, like that. Let's go to the weather tab. So in weather, you have a possibility to enter n number of weather. By default, software has taken 3 different weathers. So in weather, what all you need to do is you need to select the wind speed and select stability class. So you have A to G, which A is very unstable, sunny, light winds, and G is very stable or possibly a fog conditions. So depending on the area for which you are doing the study, you can select a weather class. Then next is parameters tab. So this parameters tab, when you start doing your study, it gets already automatically populated. You should not be changing anything here unless you know something better than the software knows. But it gives you a possibility to change some values. Like this has already populated all the values. But if you know something better, or if you want to change and see, you can change, but it should not be done unless you know really good thing. Otherwise, the entire calculation may be wrong. Then this material tab, this gets populated the way you select the materials here. But if you want to do something, add some new material which is not there in the software, you can do it from here. So suppose you need to create a new mixture, then you select this and then create a new mixture. This is the map tab. So on map, you have in FAST currently, you can upload 2 maps at a time. So what I have done is I have switched off one map, then you can see the other map. If I switch on this, and then this will be So you can place two maps in one study. And why map is placed or multiple maps are placed? It is basically to improve the resolution of the result. So you can have a very large map of that area, means that has multiple and then you have s- a better resolution map of the same area with a shorter distance. And if both the maps are correctly modeled, then it should superimpose on each other. It should not be like, means if it is not superimposed, then it is not correctly scaled. So scaling is very important. How you do scaling? You upload a map. You see there is set scale tab. Then there is set origin. It's not populated right now, but when you model a new, when you start with a new map, you will get this populated. Then you active, and then you can set the scale and set origin. Set origin is done to have, if you are having more than one map, two maps, then origin has to be the same for both the map to align the map. Yeah. Okay. So now let's do the basic run. So if we run this, once you run it, you will get a green tick on all these scenarios and also on the parent tab. So to see the results, you need to go on the scenarios. So if you see the results, you get reports. Let's see the report a bit. Yeah. So what you get in the report? So you have modeled a LPG tank and you are interested to know if there is a release, what is the release temperature, what is the velocity of release, what is the droplet diameter. You get all these information from this. Then for different weather, now you can see that with how much distance it is going for a particular volume. So UFL is 1831 meter. LFL is 4000 meters. LFL fraction is 5000 meters, means 5 kilometers, 4 kilometers, roughly 2 kilometers. And you see here that when the weather is 5D, when the wind speed is higher, then it is stopping at 3 kilometer, which something like half LFL. LFL fraction is going up to 3 kilometers. So lots of actual and means actual hazard is dependent on weather as well. See, if weather is very stable, then the dispersion will be slower and you will have more concentration at a larger distance. But when the wind speed is higher, then you will have the concentration dispersing into air quickly. So you get results for late pool fire, and as I have shown just now, that you will get results in terms of radiation. So what is the radiation up to for 4 kilowatt per meter square is up to around 2 kilometers, around 2.3 kilometers, you have this kind of radiation intensity. 12.5 kilowatt per meter square is up to 1.5 kilometer, and 37.5 kilowatt per meter square is up to 839 meters. So similarly, if there was a firewall, what could be the radiation, up to what distance? If there is a flash fire, what will be the radiation? So if there is a flash fire, what is the distance for the concentration? So you get different kinds of results from this. Also for explosion, you get what is the overpressure at a particular distance. And these things can be, say, if I want to understand that for what will be, means up to what distance I'll get this overpressure. So if you have a, say, if you already want to, means if you want to know for a particular value, you can input that into the software and you can get that values as well. The other results you get in graph and then GIS. So in graph, you see, you will be getting like the pool evaporation rate versus time, then for pool radius, pool temperature, pool depth, mass split, mass vaporized, mass remaining. For dispersion, you will get side view, maximum footprint, all this kind of data you will get. For fireball, what is the fireball dimension? What is surface emissive power? What is radiation versus distances? What is what also will get the radiation ellipse. For late pool fire, you will get radiation versus distance and also the radiation ellipse. For flash fire, you get flash fire envelope. So, and for explosion, of course, you get explosion over pressure versus distance. Worst case radii at time, radii at distance. So like these results you get. The FAST has different kind of modeling. So it has, say, let's see one simple study. Just so people who are QRA consultants in this audience, they can unmute their mic and can just give me the some data which I can play with. So I'm not inserting any map. I'm just putting a pressure vessel and I'm taking LPG. Okay, LPG is not I think they've not. Okay, so let's take a propane. Either I can make a LPG also, but let's take a propane case, propane or butane case. Okay, let's take normal butane. Yeah, and what mass inventory I should be taking? Some voice I need to hear. What is the temperature and pressure I should take? Someone has to say something. It cannot run just like this. Please tell what temperature and pressure I should be taking.
Is there any range, sir? Or we can just pick any number?
Okay. No, I think when I said this, that simply meant that person who has been dealing with this kind of calculation, they understand that what should be the logical temperature and pressure for these kind of calculation. So, okay, no problem. Let me just take something from. Okay. So we were doing a pressure vessel and let's rename it as propane tank. Propane tank. Select the material. Propane and select the volume inventory. Let's take 40,000. 40,000 meter cube. Temperature, let's take 35 degree. Pressure, let's take 10 bar. And then insert a catastrophic rupture and few leak cases. So let's do leak 1, leak 2, and leak 3. So leak 2 is 100 mm, 150 mm, and leak 1 is 25 mm. You can rename it. Okay, I've not put any map. Let's go to weather. So by default, it takes all 3 weathers. Let's keep only one weather active and make other weather exclude, just to see the results properly. We're not touching parameter tab. We're not touching material. So as I told you that if you select the material, it'll appear here, and map I've not taken anything. So let's just run this. So you can see the green tick all around. You can see the results. So let's see. Oh no. So you can see the results now. So I have taken a propane vessel with all three weathers. Actually, I tried to mute two weathers, but somehow I just thought that let's continue with all three weathers. So you can see that catastrophic rupture is going up to 80 meters for UFL and 1380 meters for LFL. 100 mm UFL not reached, LFL and half LFL results are you are getting. You are getting radiation results. So you are getting all kinds of results which we see in the example files. Now let's see the graph. Okay, so you must have seen that I have quickly modeled a propane vessel. I think within just 2-3 minutes, the software crashed once because of some regions not known to me. But my computer is getting older, it seems, and it's getting loaded with too much of data, and probably too many windows were open and all that. So, but even if it has crashed for once, I could quickly model the file and you could see the results. So what I wanted to tell is FAST software is an easy to use tool, and not only easy, it is a well validated tool for which you can accept the results. The results are validated. It uses validated models, validated equations, and it is simple to use. It is not this simple when you start using it when you are doing complex studies, but it is not that complex as well. Means you can, if you learn it, you can do it quite easily. And what all input you need the process inputs, you need some process information, understanding, and then you can get a result from this, which can be used for different kinds of decision making, right from engineering to risk management. If you have any question, you can ask now. If you don't have, then I'll enter to the next topic, Safeti. I'm waiting for your queries if you have anything. If not, I'll move to Safeti. Okay, I think you guys have no questions. Then I start with Safeti. So Safeti is the industry standard for quantified risk analysis QRA of hazardous materials. PHAST, as I shown you, it has consequence modeling capacity. Safeti is for consequence and risk both. Risk is likelihood into consequence. So Safeti means fast plus risk. So if you look at this, so if you look at this flow chart, you have some of the blocks which are in black and some of the blocks which are in red. So all the black blocks are what we could do in Safeti, what we can do in FAST. All the red are additional input to FAST for QRA, which you need to do in Safeti. So if you have a FAST file, you can use that in Safeti, but Safeti will require additional input. So you have inputs, you do discharge, dispersion, user defined, weather, toxic, flammable explosion. All this analysis is done in FAST. This study is sent to Safeti with an input of failure frequency and windrows data. Safeti has by default event trees, which takes input of population, ignition, and gives you results of societal risk and individual risk. So what additional input you need in Safeti is frequency data, wind rows, which is an average wind data. In FAST, you actually just need wind speed and weather class. Whereas in Safeti, you need average wind data, which makes it a wind rose. And then population and ignition source. And what Safeti generates? Safeti generates numerous risk metrics like FN curve, individual risk, for comparison with legislative or user-defined acceptance criteria, facilitates cost reduction in terms of losses and insurance, allows risk ranking and hazard zone identification for guidance concerning possible mitigation measures, including operations, emergency response, and land use planning, facilitates compliance with regulatory requirement of many countries with tailor-made specification incorporated into the program. So when I say facilitate compliance with regulatory requirement of many countries, it means that software is neutral to regulatory requirements. You can set the maximum and minimum limit for the risk and can check the results as per the state regulations. So different state has different regulations for QRA. Like Netherlands may be very strict. UK has relatively less stricter regulations, and India is largely whatever UK follows, we follow. China has also come up with their own regulations. Singapore has their own regulations like that. Safeti can be used for quantitative risk assessment, input to safety cases, risk-based design, plant layout and land use planning, occupied building risk analysis, emergency planning, non-standard operations, risk management, financial risk assessment. Anybody has any clue what is financial risk assessment and how it can be done with Safeti? See, earlier Safeti has a program for doing financial QRA, which is no longer there, but you can associate what kind of financial risk it has, the process has, with doing some calculation and modeling, means doing some external analysis with those risk numbers. You can come up with financial risk assessment. Anybody has any question? Any questions? So no questions, right? Okay. So now I'm going for showing you Safeti software. So if you see this, this is a bit different than the previous software which you saw. So you get a additional tab with run rows, and you have map tab, you have weather tab, you have parameters tab, you have materials tab, you have the model tab, weather tab, parameters tab, materials tab, map tab. Till this, it has all the, it has, it had, means FAST also has this, but there is an additional risk tab which has come in Safeti. So to show you this, I will start a So you can see that this also has something very similar as you saw in FAST software, but this has some differences which I'm going to tell you now. So this is the material, this is the tab for the pressure vessel, and here we entered volume, temperature, pressure in FAST, and in FAST it didn't have a tab called risk tab. Here also we are not even if there is a risk tab, we are not getting any input window for this. So what Safeti is doing is Safeti is taking frequency for the failure. So there is a tank, propane tank, fine, but what kind of failure it will have? So it has catastrophic rupture, it has leak. So what is the failure frequency for that? So here you have to enter the frequency for different scenarios. So, so like that, you have an additional input in the main model tab for risk. Then in the weather, you have three different weather for day, two different weather for night, this in this study. But here the difference is it has a wind row which has 8 different combination, which is a average wind data in that region. So QRA is not done for one particular scenario or one day. It is an average data which is representative of what risk this process carries in this particular area for a particular time. So it is not limited to a day or something. So here you have an average wind data as an input. In parameters tab, no difference. Material tab, no difference. Map tab, absolutely no difference here. But in risk tab, you get an additional tab called risk, and here you need to populate like ignition, where so you have day ignition from main road, night ignition, then the population you have to put in this, and what you do in population. So you are giving population density and population for the township or for the uh, uh, residential areas in and around plant. So you are defining different population and you are giving ignition sources. So ignition sources are going to do what? Ignition sources are going to do, if there is a flammable release and if it does not catches any ignition, then that means there has been a hazard, but there's no accident. But if there is some establishment where you have some source of ignition, or somebody is lighting a cigarette, or somebody, there is a kitchen, or there is an electric switch, that can be the cause of ignition. So this is an source of ignition in the in Safety, which you have to define. Now this entire studies are merged in Safety through run rows. So if you see this study has 4 run rows: propane storage day, propane storage night, chlorine storage day, chlorine storage night. There is a run row grid. This basically helps you to bring that study in the run rows. So if you look at this, so propane storage day has taken which all models? So you will see that it has taken all the models which we have kept for analysis in FAST or Safeti software. And this goes for all other inputs. So day weather, what all it has taken. So this is the way of combining all the different kinds of input in Safeti software. Now I will go back to the PowerPoint and will show you what is being done in Safeti. So Safeti is basically taking the consequence from different events into risk. So it is not a very simple process. For an event, suppose there is a line rupture, then line rupture can have jet fire, will have hazard zone, then outcomes in all different directions. So like that, it is taking into account all thousands of scenarios into one study, and they are consolidated cell by cell into risk array, which is finally your risk number in IR risk and societal risk. So the software is taking very complex mechanism to take all different possible consequences and assigning a value for that, and that is being merged to give you a risk result. So what it is taking all the scenarios, then event frequency, event rate probability, ignition probability, lethality probability, vulnerability level, and wind probability together gives you one number, which is IR number or FN curve. So we'll try to run this. So once it is run, you can see a risk window which is active now. We will go to the results. So you see IR reports. So risk ranking grade is not generated. It depends on the study, and explosion over pressure impulse. These are not generated because we have not used uh, explosion extension in this particular study. So these results have not been generated. But what is first and foremost report which is important in Safeti is IR graph, individual risk graph or LSIR contour, and FN curve. These are generated with this study. Let's see one IR contour. So if you see, this is a chemical plant and you have different contours of individual risk. So individual risk is a imaginary risk which anybody at any point of time will have if he is in this region. So if you see, this is 0.0 10 to the minus 4, this risk, then minus 5, then minus 6, then minus 7, minus 8, and depending on your country's regulation, which is considered as minimum and which is maximum. Beyond that is ALAP. I mean, means in between these maximum and minimum value is ALAP, and beyond minimum value is all allowed. When we look at FN curve, so this has a line between two criterion. One is maximum criterion and one is minimum criterion. This is also dependent on the country or region which you live in and where you need to. So this has taken 10 to minus 3 to minus 5, minus 3 as maximum, minus 5 as minimum criteria, and anything above this is unacceptable and anything below this is acceptable. So if you have to read this, it is like 10 to minus 5 for frequency for one fatality, 10 to the minus 3 for one fatality for maximum and minimum. But the same if you see this line, this is ending at 300 fatalities for 10 to the minus 8. So when you are giving this line, you have to tell that 10 to the minus 5 for single fatality and 10 to the minus 3 for single fatality. If number of fatalities are increasing, the frequency is not the same. So this is graph, and in between you have, if you have this plant graph, then it is under ALAP. ALAP is the region between maximum and minimum line criteria. Yeah. Okay, I think I have touched all the points for FAST and Safeti. If you have any questions, we'll take some questions and then we'll close for today. Pratika or Pranav, anybody there?
Yes, we are.
Yeah. So what we will do now is we'll take some
Mhm.
questions if somebody has, and I think we'll take this KFX in next session or some other session.
Sure, definitely.
So during the webinar, we just had one question from Mr. Ajit. If you could give a background intro to FAST and Safeti, would like to know. I think uh, if you could just give a very short, brief recap of the introductions, I think it would benefit Mr. Ajit.
Okay, that is okay. That will take up. Yeah. Any other question? So, Mr. Rajit, sorry, you'd like to know historical reference or what is that? Say FAST and Safety are industry recognized tool for consequence analysis and QRA. So FAST does consequence analysis and Safety is a superset of FAST. So if Safety can also do consequence analysis and risk both, but FAST cannot do risk analysis. So FAST is a tool for consequence analysis and Safety is a tool for consequence analysis and a QRA. Yeah, alarm, say what happens is when we do when we are running any process, so ideal is we stay out of any risk. So we stay below the minimum criterion line set for individual risk or societal risk. So I think it is known as low as reasonably practicable. So it's like it's this reason is falling between the maximum and minimum criterion. So if you have, say this, if this is the maximum criteria and this is the minimum criteria, in between this is allowed, but you need to take measures. You cannot, you're not, I mean, nobody is telling that your risk does not have, I mean, your process does not have a risk, but this is allowed. So this is a reasonably, this is allowed, but you have to take precautions in allowed prison. Same goes in say individual risk. Say if you are, okay, so let's see the result here only. So say this is, if the minimum criteria is 10 to the power minus 3 and maximum is 10 to the power, so, so the maximum is 10 to the minus 3 and minimum is say, 10 to the power minus 7, suppose. So in between this is allowed region. So 10 to the power minus 7 and onwards is tolerable risk. Means it's broadly acceptable risk, and 10 to the power minus 3 is intolerable risk, and in between this is tolerable risk. So ALAP is basically a tolerable risk. So if I go here, say this is intolerable. So anything outside this red line is intolerable, and anything below this green line is broadly acceptable, and in between this is tolerable risk. So this is ALAP. Okay, historical info of Safeti and FAST. Okay, I think I've not taken that in this particular year, but I think it's around 30 years of existence in this market for more than that. Yeah, maybe around 35 years of existence of this software. It was developed by Technica, and DNV acquired that software, both FAST and Safety, from Technica. And that's how Technica this became a DNV software. So does that mean even if a small part of event curve is above the criterion line, then the risk is, yes, it is unacceptable. The entire line of your plant has to be within the maximum and minimum criteria. Any question on, say, historical info? I'll send it to Pranav. You can have a look on that. I do have that, but I have not prepared because now people don't look for historical info. So I have not given that, but yes, it was developed by Technica, which was known as DNV Technica. For some time, and then it, I think 35 years, close to around, yeah. So it all started with Vazan, I think, which was at MS-DOS consequence analysis tool. And then FAST and Safeti was developed for different requirement by government, and yeah, then it became a tool for everyone to do this analysis for regulatory approvals. But year wise also, I think I have something. I'll send it.
Nagmani sir, it's 1980s Technica developed fast and Safety.
Yeah, that's what.
Any other questions from our participants?
Mr. Stolle wants to send a message, but maybe he's not able to send any message. So can we just wait for a minute? Maybe he's rejoining the meeting. There is some glitch from his end. I guess there is some technical issue from his end. Yes, we can.
I think that's all. We can close it.
Yeah,
Yeah. So you can do this closing.
yeah. Vote of songs. Thanks. Yeah,
Yeah,
Ritvika.
yeah.
Yeah. Thank you everyone. Thank you, Mr. Nagamani. So I'll just proceed with the vote of thanks and conclude the session. So good evening, everyone. As we come to the close of today's session, it is my privilege to extend our sincere gratitude to everyone who made this webinar possible. First and foremost, on behalf of Greenstat Asia, I would like to express our heartfelt appreciation to Mr. Nagamani for delivering a very insightful and engaging presentation. Thank you for taking the time to introduce DNV's software suite, FAST and Safety, and for clearly explaining how these tools support consequence modeling, quantitative risk assessment, and safer engineering design. Your expertise and practical insights have provided our participants with a strong foundation for a more advanced sessions that lie ahead in this webinar series. We would also like to extend our sincere thanks to DNV for partnering with Greenstat on this knowledge sharing initiative and for your continued commitment to advancing process safety and hydrogen safety capacity across the region. Our gratitude also goes to all participants who joined us today from academia, industry, government, and the research community. Thank you for your active participation, thoughtful questions, and your enthusiasm throughout the session. Your engagement is what makes this webinar truly meaningful. So we hope today's webinar has provided you the proper insights into the ecosystem. And we would like to inform all the participants that the meeting's recording will be mailed with all the participants. And please do let us know if you would like to be in, if you are interested to receive updates about the next webinar in the chat box. And we look forward to welcoming you to our next session, where we will continue building on today's concepts. And also, as Mr. Nagamani said, KFX would be picked up, for more in-depth discussions and practical applications. Thank you once again to our speaker, partners at DNV, and each one of you for joining us today. Have a wonderful evening, and we look forward to seeing you with our next session of the risk assessment and safety webinar series. Thank you, everyone.
Thank you.
Thank you so
Yeah,
much.
thank you.
Thank you, Pritika. Thank you, sir.
Thank you, sir.
Thank
Thank
you,
you, Mr.
everyone.
Nagamani. Thank you, everyone. Thank you.
Thank you.
Thank you, Mr. Vedita. Thank you.